How are you guys doing today?
Doing okay.
Okay, it's good these days.
Yep. Before we start class, can I ask a couple questions? Well, it's really
Yeah.
just one question. So about the labs,
Yes.
there's a lot of the commands that do not work with packet tracer.
Yes.
And I put in there that either like when I write it out and I go through and I do the lab, I write out it's not compatible with packet tracer.
Yes.
And then I put in like what results I got, and then I state I don't know whether that's the correct response that I should be getting from packet tracer for the assignment.
Okay.
Do you find that to be an acceptable response?
It's very acceptable. Thank
Okay.
you. This is good.
All right. And are you expecting us to try to find the workarounds, or no? Since it's
I expect you to be creative and try.
okay.
So I don't
Because
know
I
if
wasn't
you,
sure, since this is like a scripted assignment, we're only supposed to enter these commands,
yeah.
like if we're supposed to go headhunting for it, or if we're just supposed to follow the script.
Follow it where you can, and when you hit the wall, see if there is a way around it.
Okay.
And I know it's frustrating for some of you. We're all adapting, including you. And I think the search is good and useful skill. So you're saying, okay, I can do this. Is there something similar I can do that packet tracer would accept? And that's
Okay.
a part of the educational process.
All right. So yeah, just as long as we're put in that, obviously we don't know what the correct response is, but as long as we've done some effort to at least figure something out, then we should be okay.
You're good.
Okay. Thank you.
Sure. All right. Good morning, everybody. It's 10 o'clock. Let's go ahead and get started. So this is the plan for the quarter. I want to do a very quick review of ZPF, maybe 10, 15 minutes at most. And this is chapter 4. And we're going to be covering chapter 5 today, and we'll do chapter 6 next week. And when we started this course, I was a little nervous about covering all of this in 9 weeks. But things are going very, very well from my perspective, and I'm no longer concerned about that. I'm quite confident we will cover everything that I would like to cover in the remaining weeks. So we're doing well there. I'm not stressed about it like I was early on in the quarter. So let's do a quick ZPF review. Zone-based policy firewall. I said no one really expects you to have working experience, but they probably expect you to know what it is. And it would be a new skill set that you will be learning. And we said it abstracts a lot of the lower level complexity. This is the benefit. So when they ask you what's the advantage of a ZPF firewall, it operates at a higher layer, it has a higher scope, and it does abstract some of the lower level stuff. And this is really a great example, everybody. So let's say this is a company and they have 2 different sites, and they have a DMZ, and of course they work with the outside world. And we have 3 zones here. So we have the DMZ zone and we have the public zone. And then because both of these sites, physical sites, belong to the same company, it is 1 zone. And the firewall rules are quite relaxed between these 2 private sites. And you have 1 set of policies between private and DMZ, and you have a different policy between DMZ and public, that is the pair. And then of course we have a 3rd one between public and private. And this is what ZPF would be able to do. So to come back to my table, last time we were looking at permit IP range any, or permit IP any. And I said IP and ICMP are 2 different protocols, and that is correct. And I incorrectly said that, if you enable IP, that doesn't automatically enable ICMP. And then I found out IP means any IP-based protocol. Any protocol that requires IP to communicate with the other computer. And when we ping, for example, we use the IP address, and that is IP enabled. So I just want to stand corrected here and say, yes, they are two separate protocols, and you can have two different ACLs, one for IP and one for ICMP, but enabling IP will enable ICMP. So let's do a quick lab, and then we'll say goodbye to chapter 4, and we will cover chapter 5. And I don't think chapter 5 is going to take us an awfully long time to do, and we only have 2 labs. So let's do it. So I added a little bit to this lab, and here we are. So we're using a Net Academy lab, except I've made quite a few changes that I just added to it. I didn't change anything. I just added a bunch of stuff to it. And I added the following 2 tables from the slides to the file, ZPF rules for transit traffic. This is basically when you're going between 2 different zones. These are the rules, okay? And where it says inspect, you're inspecting an ACL. So we don't have to use an ACL, but if you want to inspect, then you have to use an ACL, because that's what we use to inspect. And then of course we have a different set of rules when you are communicating between devices inside the same zone. Makes sense, everybody? So if you're in the private zone, and the private zone consists of 2 or more sites, you have one set of rules. And if you're in the private zone and you want to go to the public, you have a completely different set of rules, and that's what you want. Okay. And then we said we followed the 5 steps. We create the firewall zone, and this is what we had last time. So I'm going to leave it like it is, and then I'm going to come back and I'm going to change the this said IP. I changed it to TCP. Okay. So this is what we did last time, and we were able to do anything we wanted from the inside out, because it's permit IP, and this is the range of IPs inside the end zone, and we weren't able to do anything from the outside. And of course, like any access control list, the very last statement is an implicit deny IP any. But IP allows us to do all the IP enabled activities. So this is what we did last time. And what I'm saying here is let's change this IP to TCP, and then let's copy and paste. So remember, coming back here. Okay. So IP is all IP enabled, which is TCP and UDP, and all the individual protocols that sit in the top of TCP and UDP. And TCP is only TCP, not UDP, and all the protocols that sit in the top of TCP. And I hope you're becoming comfortable with this, like FTP, Telnet, HTTP, POP, IMAP. All of these use TCP. And then UDP are the UDP protocols, like DHCP has some, DNS is definitely UDP. And now we're saying we're only enabling the TCP, and of course, TCP does not include ICMP. So let's copy and paste and see what's going to happen. So I'm just going to copy. The only difference, the only change I made, everyone, I changed IP to TCP. So let's copy and paste. The rest of it is the same. And we're applying it to 3. And apply. So we made all the changes. Okay. And I can do show run and see everything that I did. And show zone pair. Remember, we have to pair security, and I have the in zone and the out zone, and that's all I have here. I don't have a DMZ. I don't have other zones. I only have these 2 zones, and I'm pairing those 2 zones to one another. So let's come over here. And if I was to go to the outside, I'm not going to be able to do anything from the outside in, because the rules says, drop. So I'm going to try and ping into the inside, and it's going to fail 192.168.3.4. Okay, so we'll give it a second and fail. Okay, and we can try an FTP. And remember, FTP is a TCP-based activity. TCP, how about FTP? And that's going to fail. And HTTP is the same. And if I was to do it from this end over here, so let's start with this computer. And if I wanted to ping, it should fail because we're only enabling TCP. And ping requires IP. So if I was to try and ping to the outside, that is going to fail. And then I'm gonna FTP, HTTP, any TCP activity is going to work. So if I was to FTP, that worked. If I was to HTTP, that will work because that is TCP based. Okay, and if I was to come over here and try and do NS lookup uses UDP, and that should fail because we only enable TCP. And if I was to do NS lookup, and before I do this, just want to show you, I did configure a DNS server, and it's this outside server. So it's going to try and go to this server to resolve the name to an IP, but I can't get there because that is a UDP activity. zico.com, and it's not going to go anywhere. It's not going to get there. Any questions about ZPF or what we just did? Mostly a review, just wanted to correct the ICMP and IP. And if we wanted to enable TCP and UDP but not IP, then we'd have two separate lines. We'll go back to the file and we will add a second ACE, and it would say permit UDP. And now we're permitting TCP and UDP but not IP, just for any other protocol that isn't TCP, isn't UDP, but requires IP. How is your comfort level with firewalls? Everybody?
Good, Zico. I'm pretty comfortable. I was looking at my licenses on my on my gateway, and I noticed that I have the Security K9 lifetime. So I guess when I bought this, they had already activated it. I wanted to also point out, I can't remember whether on Tuesday you ran when you specified the in global config mode, the IP inspect name,
yes,
the name of the, and then you can specify UDP, TCP. I did that, and then after I applied it, I couldn't actually get return traffic, and what I had to do is I had to put the IP inspect name of the list.
Can you send me the syntax, Cody?
Sure, I just had to append router-traffic at the end of it to get return traffic.
Okay.
I guess you have to inspect local traffic as well for it to work, is what I sort of noticed.
I don't know off the top of my head, and I don't want to assume, but if you can send me an email, I would appreciate it with whatever comments you want.
Okay.
And then we will take it from there. How about the rest of you? Like I said, firewall is a ground level skill set. And we use firewalls every single time you do anything. Your PC has one, your wireless access point has one, your ISP routers have firewalls. Wherever you end up going, Gmail, Facebook, etc., they all have multiple firewalls. So we go through a bunch of firewalls to get anywhere out in the internet and come back. And it's a basic skill set for a network and system administrator. This is something that they will quiz you on. This is something that they expect you that you know a good deal about. Not everything. It's a huge area, but enough. So anybody?
As far as like the general idea of firewalls, I'm fine with that. I haven't really looked over the
Lab?
yeah.
Yeah, I think that would help you. Just, do it at your own pace, at your own speed, and make sure you understand. Don't move on if you don't understand. So that's my recommendation about all of the labs is make sure you understand before you move on, or you're just going to get more confused if you just move on without knowing what the previous lab or the previous part of the lab did. Okay. So we're done with firewalls, everybody, and we said firewalls is a security tool. So we use it. It does a wonderful job. It's a legacy solution. It's been around for a long time. Of course, we keep refining it and improving it, but firewalls have been around for a very long time. And like the slides said, we can't just rely on firewalls for security. It's just one of the many tools, one of the many security tools we use. Another common security tool that we all use is an anti-malware. So again, that's another legacy security tool that's been around for a very long time, and we keep refining them and improving them. And it used to be just antivirus in the good old days, and then antivirus, anti-malware, anti-worm, anti-adware, spyware, more recently ransomware. So it does all of that good stuff. And we have a signature file. So for every known virus, there is a signature, and we put all these signatures in the signature file. And I'm talking about it because it's relevant to what we're going to be talking about next, which is IDS, IPS. And of course, there are new malware every single day, and every single day there is a new signature file. And hopefully you magically update the signature file on a daily basis. I use Defender, Microsoft Defender, and it uses Windows Update to keep the signature file up to date. And sure enough, it does update every single day because there are new malware every single day. And it only protects you against the known malware. So if there is a 0-day malware, something fresh out of the oven that the semantics of the world, the Microsofts of the world, the McAfees of the world don't know about, you're not protected against that. And that's why I say there is no 100% protection against anything. But 99% point some percentage is much, much better than 0. And in fact, maybe it's your own experience or you read about it. It doesn't take very long for a computer that doesn't have an anti-malware to get infected. So you install Windows 10 on a brand new computer, you expose it to the internet, and you could be counting seconds before it gets infected. And an anti-malware protects you from the known malwares. And it's an increasing list, and we're talking about millions of known malwares out there that are included into that signature file, and every day they add new ones. As far as new ones, how do they know about the new ones? Usually it's you and me that get bitten by it, and then we escalate, and then McAfee and semantics say, oh, okay, yep, it looks like we have a new malware. And then they determine the signature for it. They add it to the signature file and make it available for everybody. And there's an elapsed time. So if I was to write a new malware this afternoon that has a different signature from the known signatures, it's going to be a few days before it's going to reflect in the new signature file. So that's another tool. And IPS, IDS is another security tool. And this is what we're talking about. How many of you are familiar with the terms IDS, IPS? How many of you have used semantic endpoint? Semantic endpoint, it's a product for your PC, for your server. That was the default anti-malware for a few years when I worked for Hewlett-Packard. And I want to show it to you because it is a suite. It is a suite of security products. So they took all the different products that semantics thought people needed for security, and they bundled them into a suite, just like Microsoft did with Microsoft Word, Excel, PowerPoint, etc. They bundled them into a suite So if I was to come over here and do semantic endpoint, I wanted wiki. Is that wiki? No. And let's just read the first line, everybody. This is very much in scope for what we're talking about today. Semantic endpoint protection developed by Broadcom Inc. is a security software suite. It's not the product, it's a suite of products, okay, that consists of anti-malware. We just finished talking about it. And by the way, you no longer have to pay for anti-malware. Okay, it's just a legacy solution that's available from many different vendors, and almost all of them provide a free version. Microsoft has Defender, and Defender is an excellent anti-malware, but it's just an anti-malware, you know, virus, worm, adware, spyware, ransomware. And then intrusion prevention. This is what we're talking about, everybody. IDS, intrusion detection, IPS, intrusion prevention, firewall, okay, for servers and desktop, okay. And it has the largest market share of any product for endpoint security. And endpoint security is an umbrella term that talks about these different suites. And all of these security companies, they have a product and then they have a suite. And if you want, you can purchase the suite and it will give you all these different capabilities. And like I said, you know, I did use semantic endpoint for a few years at Hewlett Packard. I wasn't highly impressed because it was a massive suite. It was just a very, very large suite. And this is back in the days when computers weren't highly capable in terms of CPU and RAM, and it slowed you down, in my opinion, significantly. And I wasn't sure, you know, if we're getting any additional value out of it, because I have a firewall, thank you very much. And I have, all I need is an anti-malware. And that intrusion prevention, I was never sure how good it was. You know, I'm talking 10 years ago, how good it was, maybe even more than 10 years ago. So I wasn't sure if I was getting any value out of that massive suite. All right, slides. Zero day, I think you all know what that is. This is basically brand new malware. We just don't know about it. There is no signature for it. Okay, there is no signature for this attack or this malware. It's brand new. Okay, and anti-malware solution is not going to protect you from zero-day attacks, zero-day malware. This is what this is saying. So we have to rely on other tools for that. So the firewall is going to protect you from that. Your anti-malware is going to protect you from that. So how do you protect yourself from those kind of attacks? Okay. So IDS and IPS, everybody, intrusion detection and intrusion prevention, and they are very, very similar, two very similar tools. The big difference between the two is IDS is passive offline. It works offline. So you're sending a copy of all the network traffic to the IDS, but it is working offline. And that has pluses and minuses, and we'll talk about that. And intrusion prevention is active inline. So the network traffic is going through the IPS before it gets to its destination. And if the IPS thinks this is malicious, then it can do something about it before it arrives at its destination. IDS, it's passive. So it's going to get to its destination. It's going to do whatever it was meant to do. So this is the huge difference between IDS and IPS. And by the way, IDS is nothing new. The technology has been around for a very long time. However, it's quickly evolving. So when we talk about innovation, there isn't really a whole lot of innovation happening at the firewall front. There isn't a whole lot of innovation happening at the malware front, but there's an awful lot of innovation happening at the IPS front. So all these security companies, that's where they're investing a lot of their brain power is, you know, not so much the firewalls, they have that, not so much the anti-malware, they have that, but it's that intrusion prevention, which is what we're talking about today. So IDS works passively, it is offline, requires traffic to be mirrored. We have a lab about mirroring. where basically, remember, a switch is a switch, it's going to filter. Well, what if you have a management console? What if you have an IDS sensor? Well, we want the traffic to go there, and then we want a copy of that traffic to go to that one port where the IDS is implemented. Very good. And then the next slide talks about IPS, intrusion prevention, okay, implemented in an inline mode, meaning it's active, okay, and you can actually see it. I want to go back. So this is the traffic, okay, it's going to get to its target. We're just sending a copy to IDS. And in intrusion prevention, the sensor is inline. Okay, so the traffic is going through the IPS, and that has its pluses and minuses. It's almost always a mixed bag, but we're able to do something about malicious traffic before it hits its target. That's the huge difference between the two. And this is why IPSs are more desirable, because they have the capability of doing something about it instead of just reporting it later on. Layer 3 and layer 4 can stop a single packet attack from reaching target and responds immediately. So you can send the malicious data to a bit pocket. You can prevent additional data from coming in from that source IP or IP range. So you have a bunch of different options to respond to what you think is a malicious attack. Similarities, they are very similar. They fundamentally do the same thing. The big difference, everybody, if it does come up during an interview, is IPS is active, it is inline, and IDS is passive, it's offline. And IPS has the capability of stopping malicious. IDS, you react to it later on. Okay. And I think that's what I just said. Advantages, IDS, no impact in the network. So you're not slowing down the network because the traffic is not going through that IPS sensor or sensors. No network impact if there's a sensor failure. It doesn't really matter because you're not going through that sensor to get to your target. No network impact if there's a sensor overload, because that's another device that you have to go through before you can continue in your journey. Disadvantages is response action cannot stop the trigger. So the data is going to get to its target. Advantages of IPS, stops trigger packets. Okay, so if you suspect this is a malicious attack, a malicious data, you can stop it, you can do something about it. Okay, disadvantages are the sensors. So you have these sensors in line, and they're going to slow you down a little bit. And if they get overwhelmed because there's a lot of traffic going through them, then they're going to slow you down a lot. And this is why Cisco has a suite of IPS products saying, you know, how much data do you expect? 10 megabits per day, we have product for you. 100 megabit, we have a different product. 10 gigabit, we have a different product. So they have a suite of IPS products to range from a small, slow network to a very large enterprise level network. Okay. And we'll talk more about disadvantages later on. This is really important slide, everybody. We have a host-based and a network-based. So we talked about semantic endpoint. Well, semantic endpoint is a host-based IPS. It runs on the PC, it runs on the server. And then those sensors I showed you in the previous slides, okay, and these are network-based. They're not running on Windows 10, they're not running on a Linux operating system, they're running on the network, okay. And as you can imagine, one of the advantages of a host base is it can look at encrypted data, because by the time it gets to the host, you decrypt it, and now you can see the payload and you can take action on the payload. The network-based IPS, you know, you can see the encrypted data, you can see the header and the footer, because we have to have that to figure out how to route that packet. But the encrypted data is encrypted, and there's no way for a network-based IPS to see the encrypted data. And that is a disadvantage for a network-based IPS, is you can't act on the encrypted data. Okay. Disadvantages, operating system dependent. So there's one for Windows 10 and there's one for Linux and there's one for Mac, etc. Okay. And down here, you know, we cannot examine encrypted data. That's really the one huge difference between the two, over and above scope. And scope, as you all know by now, one of my favorite words. If you install an IPS on a PC, the scope is tiny. It's that one PC. And if you have, you know, 150,000 PCs, well, you're going to have to install that host-based IPS on all of these devices, which may not be a bad idea, but it's a lot of devices. Versus if you put it in the network, then you only need a few sensors because all the traffic goes through that connection to get to everybody else. And of course, you know, the network-based scope is much bigger. So host-based is, the scope is the host, and network, it's the entire network. And what is super common, everybody, and I want you to visualize this if you haven't seen it, what is super common everywhere, you go to any company, anywhere, and there's a router that connects that company to the ISP, or, you know, one or two ISP connections, and then immediately behind that router, there's a security device, like an ASA. And we'll talk more about ASAs later on. That is very, very common. So we have a router that connects me to my ISP, and then security takes place immediately, you know, behind that router, which basically means all the traffic going outside to the internet and coming in from the internet is going to have to go through those security devices. And it's a firewall, it's an anti-malware, it's an intrusion prevention, and anything else you want. Network-based, just finished talking about it. So we have the corporate network and you have sensors, okay, immediately behind the router for that corporate network. So all the traffic is going to go through that sensor before it gets inside the corporate network. I talked about the Cisco family of IPS solutions, and they range from a card, a module that you can buy for a router, and you plug it in the back of the router, and it gives you that, it's basically a computer, okay, and it gives you that IPS capability to dedicated devices, okay, and the difference is the cost and how much data they can handle. Remember, it's inline, and you don't want it to be overwhelmed because it's gonna slow the network down. So, you know, do you have 10 megabit, 100 megabit, 10 gigabit, and then Cisco is going to say, no big deal, we have a solution for you. Very good. Okay. So factors affecting IPS sensor selection and deployment, amount of network traffic. I already talked about that. Network topology, exactly. And this is why a lot of people put those devices immediately behind the router that connects the enterprise to the internet. And that's a perfect place. I'm not saying that's the only place, but you certainly want a firewall there. You certainly want an anti-malware there, and you certainly want an IPS there. Why let it in? You know, don't let it in. Okay, capture it as soon as, not as soon as, before it gets into your enterprise. Budget is always a big deal. And of course, you know, the sophistication of your staff. Okay. Still talking about pros and cons. Network IPS is cost effective, not visible in the network. You know, nobody knows it's there. So your users don't know, just like they don't know there's a firewall protecting them. They don't know there's an anti-malware that's protecting them. They don't know, but it's there and it's doing its job. It's an operating system independent. So if you have a hybrid environment with Windows and Linux and Macs and et cetera, it doesn't care, except remember the disadvantage is it cannot look at encrypted data. And that's something you want to remember. And more data is encrypted these days, and you can't see the payload inside that packet. Promiscuous mode, inline mode. I think the inline mode is straightforward. Everybody, promiscuous mode. And this promiscuous mode isn't anything new. It's been around for a very long time. In fact, I want to bring my table back up just to show you something. And I'm looking at the NIC, the network interface card, and you can see NIC is unique. It's the only device that sits at 2 layers. So we have a NIC at the physical layer, and we have a NIC at the data link layer, at layer 2. And down at layer 1, okay, the NIC is sending zeros and ones and receiving zeros and ones, right? This is what we do at layer 1. And at layer 2, we're filtering on the MAC address. So that NIC has a MAC address, and then when it receives a frame, okay, it's going to look at the destination and say, nope, this doesn't belong to me, and it's going to discard it. And NICs do this by default. So if you do nothing, this is what the NIC is going to do. Why send it in? Okay, it's just a waste of resources. So you want to stop it at the door saying, not mine, not mine, not mine, not mine. And if you want, if you have some networking application running on that computer, if you have a monitoring tool, an IDS tool, or any kind of a network monitoring tool running on that computer, you want all that data to come in. You don't only want the data that is destined to that device to come in. And then you set the NIC in promiscuous mode, which basically says, let everything in. Please don't filter, turn that filtering option off, let all the traffic in. I need to see all the traffic. So this is what we are talking about here. And that's called promiscuous mode. And some of the NICs, have that capability. You can actually configure your NIC into a promiscuous mode, and it will no longer filter. It will just turn the filtering off and will let everything in. And that is required if you have some kind of a network management tool running behind on that computer. Any questions on this? So IDS requires this, and this is IPS. So this is IDS over here, because we still want all the traffic to go to the IDS, to the offline IDS sensor, and we have to mirror, and I will show you that, all the data coming into that port that has the IDS behind it. And here we're inline. We don't really need to do any of that. Port mirroring. How many of you have heard the term? We've done port mirroring before. I'm quite confident we've covered port mirroring before. Okay, and port mirroring is basically saying, on a hub, there's nothing to do because hubs broadcast everything. So there's really no need for port mirroring here. But nobody uses hubs anymore. We all use switches these days, and switches filter. And if you have a packet analyzer over here, then you want a copy of the data to go to that port. And this is what port mirroring means. Send a copy, mirror. A mirror is a copy. Send a copy to, I know it's only going to port 1, but please send a copy to port 24. And I know this is only going to port 2, 3, 4, 5, 10. Send a copy to port 24 because there's a network application running there that needs to see this data. And we do have a lab, okay? And this is, the mirroring command. So we'll get there. And they're showing us the syntax, and we will do that. IPS, very good. So now we're focusing on IPS. And we're focusing on IPS because IPS is what we want. We don't want to log a malicious activity. We want to do something about it. And to do something about it requires an IPS. So we have a signature is a set of rules that an IDS and IPS use to detect typical intrusion activity. So this is the signature of an intrusion activity, not the signature of a malware, which is the signature of a file you're downloading. This is the signature of an intrusion activity. And signatures have 3 distinct attributes: the type of the attack, what kind of a trigger do you want to generate, and then action. And action is really, really important because this is what you're going to do about it. Am I going to let it happen? Am I going to send it to a pickpocket? Am I going to generate an ACL to prevent future data from that source IP to come in? And you have a bunch of options, and we'll go over these options later on. But action is very important. This is the whole point of IPS, is that you have the ability to take action. Otherwise, it's just an IDS. Signature type, so we have atomic and composite. Atomic is just a single independent packet, and a composite, this type of signature identifies a sequence of operations. Okay, so this is a single packet, this is a sequence of operation. And then we have the signature files. It's not just a signature file, everybody, like it is on anti-malware. So you have an anti-malware and you have a signature file that hopefully you're keeping up to date each day. And with IPS, we have a bunch of different signature files. And as you can imagine, those signature files are signed by Cisco in this case, because the vendor is Cisco. And then you need to be able to verify that this file was signed by Cisco. And we've talked about file signatures before, which means, you really need to have the Cisco public key, because the file is signed with the Cisco private key, and you need the public key to be able to do that. We don't really need to do that stuff on the PC, because all these public keys, at least the generic ones, are already populated into your digital certificate database. And then what we want to do here is we want to save it in the configuration file. Okay, and that way you don't have to provide the public key every time you want to verify a signature file, because those signature files change, I don't know if daily, but regularly. And every time there's a new file, you want to download it, and you don't want to have to provide the public key one more time. So you capture the public key in the configuration file, and you're done. And every time you download a new signature file, you can verify this really did come from Cisco, not someone pretending to be Cisco, and life is good. Make sense, everybody? Okay, remember, this is iOS. This is not Windows. This is not Mac. They don't have a database of public keys and certificate authorities, etc., because you don't need it, but you do need the public key for Cisco, and that's one manual activity you need to do once, and you're done. So we have micro engines, okay, and I will show you later on a slide of these micro engines for these different kind of traffic. So we have one for atomic signatures. We talked about atomic being a single packet. We talked about service. Well, service is a service or a set of services. A micro engine, a string, where you're basically trying to capture a string and compare it to known malicious strings to see if that is a malicious activity or not, multi-string or other. So we have a bunch of different signature micro engines, okay, SMEs. And for me, SME is a subject matter expert from my project management days, except in Cisco lingo, SME is a signature micro engine. Here we go. So we have alarms and we have actions, right, everybody? So we capture, detect a suspicious activity. Okay, what's the alarm? What's the action? So detection type, a pattern based. Okay, it matches a pattern of malicious activity. Anomaly, this doesn't really make sense. It's an anomaly. Okay, policy based, you have a policy, everybody, and you can create those policies yourself, but you really have to know what you're doing. So this is not something that your average system administrator can do, but security specialist can say, okay, I'm going to create a security policy trying to look for suspicious activities. And honeypot based, I hope this is not a new term to anybody, a honeypot. This is basically where you redirect the traffic to a honeypot, and you can monitor and you can learn. And you can do it on a production environment where you suspect this activity is malicious activity, and you redirect it to a honeypot server, so you can monitor and see what is it they're trying to do and learn, monitor and learn, because they know what they're doing, and you want to learn from the experts that are trying to hack into your environment. And you can do it for your own educational purposes. So when you're learning, you may want to create a honeypot just so you can monitor and learn yourself. Okay. I'm going to move on. Okay, and they're giving us some examples, which is really, really nice, everybody. So they're saying pattern-based, okay. If it's atomic, a single packet, of course, you know, there is no state. It's just a single packet. You can't have a state with a single packet. If it's a composite, like a TCP, everybody, okay, then we have a state and you have a lot more data. And here they're giving us the example is, we all know what an ARP is, address resolution protocol, that has the source Ethernet address, not the destination. We know the destination is all Fs because it's a broadcast message. But if the source is all Fs, that's a problem. And they're saying, aha, you know, something fishy is going on here. Let me do something. Maybe just send it to a pickpocket because clearly this is a bogus ARP request. Okay. Anomaly, okay, if it's atomic, if it is composite, detecting traffic that is going to a destination port that isn't in the normal profile. You know, you don't have any services on that port. Then, you know, why are they trying to go to this port? Okay. Policy-based, and remember, this is an area where experts, okay, can create more policy-based scenarios, and then they can take an action based on that. Detecting abnormally large fragments, packets, by examining only the last fragment. Okay. So benefits, I think we've covered this. I think we've talked about the benefits of an iOS, the Cisco operating system, IPS. It uses underlying routing infrastructure to provide an additional layer of security. You just buy that module and you plug it into a router, you plug it into an ASA appliance, or you, if you have an awful lot of data, you can buy a dedicated appliance for that. It is inline, so we've covered that, and is supported on a broad range of routing platforms. It provides threat protection at all entry points. This is exactly where you want to have sensors at the entry point, everybody. So you have a router that connects you to the internet immediately behind that. So not too long ago, maybe 3 months ago, I was given a guided tour of the tiny LBCC data center, and that's exactly what they have. You know, they had a router, and then immediately behind the router, they had an ASA appliance. And we will cover ASA in chapter 9, 10, and 11. Okay. And the size of the signature database, very good. So there are lots of signatures, and they consume a lot of RAM. And Cisco said, if you don't have a whole lot of RAM, don't worry about it. You know, we have different flavors of the signature files. We have all categories, which includes everything. We have advanced category, which has a lot, but not everything. And then we have basic. So if you have a low-end router, don't worry, you know, you can still have some signatures. You're not going to be able to load all of them into RAM, and we need them into RAM for efficiency and speed, but you would be able to load a bunch. And that's what that last bullet is talking about. Questions before I talk about false positive and false negative? So would you agree with me? It's fairly easy to explain what IDS, IPS is, the difference between IDS, IPS, and where they play in this security suite. It's not a firewall. It's not an anti-malware, right, everybody? So there's a space for firewalls, and there's a space for malware. However, IPS occupies a different space in the security suite. And if we are to go back to semantic endpoint, the most popular security suite, this is exactly what it includes. It includes a firewall that takes over the Microsoft firewall, and it includes an anti-malware, and it's an IDS/IPS. Questions before we move on? Okay. Let's talk about false positive and false negative, everybody. But before we talk about, let's talk about true positive and true negative, because those are really easy. True positive is, yep, you know, I was right, that was an attack, okay? And true negative, yep, I was right, that was not an attack, okay? So this is ideal settings. Okay. So let's talk about false positive. False positive is when you look at the behavior of the traffic and you determine, this is malicious and I better do something about it. And it turns out that it wasn't malicious. This is what a false positive is. Normal user traffic, alarm generated, you took some action and you stopped that user from doing their job. And you want to avoid this. But before we talk about is this good or is this bad, we really have to go back and talk about the risk appetite of the company. You know, what is it you're trying to protect? If this is a financial institution, you know, then their risk appetite is very, very low. And they're going to tell IT, okay, IT, you know, we give you permission to take some strict measures. And if you end up generating a bunch of false positives each month, we will protect you and we won't penalize you for it. And of course, every time IT generates a false positive, they will tune the alarm. They say, okay, you know, that wasn't right. Let's tweak it a little bit. Let's change it a little bit. Otherwise, the same thing's going to happen the next time. Okay. And if you're a company that doesn't care a whole lot about security and you're generating a bunch of false positives, then they're going to complain to IT. So if you want to see what movie is playing at the AMC theater next door, and they say, wow, this looks like a suspicious activity, and the movie theater is saying, what the heck, it's just a listing of the movies. You know, it's not like we have some sensitive data we're trying to protect. So you always have to go back and see what is the risk appetite for the company. And that is going to dictate whether you want to be relaxed or aggressive. And I know you're all nodding and agreeing with me, which is good. And this is really, really important to know because there is no one size fits all for anything. And this is why almost always the answer is it depends. Okay. False negative is where the attack happened and you had no clue. So all of your sensors were green, everything is looking great, and a genuine attack was going on in the background. And of course, you want to learn from that. And you want to create a policy for that. So next time it happens, you know, something will be triggered and action will be taken. So those are the two that we really have to pay attention to. The false negative, you know, something bad happened and we had no idea. And false positive is normal user traffic that we prevented because it looks suspicious to us, and you want to tune the alarm so it doesn't happen the second time around. And these will happen, you know, false positives and false negatives will happen when you implement an IPS solution. It's unavoidable unless you're very relaxed about the security, and you know, it's not that hard not to generate very many false positives. You just relax the security. But if you want to be strict and you want to be able to capture a lot of malicious looking activities, then you're going to start generating some false positives. And as long as the company is behind you, as long as your management is saying, yes, this is what we want you to do, this is what we hired you to do, so don't worry about it, just, you know, do your job, tune the alarms, so the same thing doesn't happen over and over again. But let's continue to be aggressive in protecting our data. All right, IPS. Summary of actions. So we talked about type, we talked about alarm, and we talked about action, right, everybody? So we're down to action. So we can generate an alert. It's just an alert. Hey, everybody, there's an attack going on. Log, of course, you want to log. You always want to log because that's all you have after the fact. And I'm not going to go over that one more time. We've covered it a couple of times before. You know, logging is super important. You want to log everything. That's all you have after the fact. And then you have to go back and mine your log files. Okay, dropping, everybody, or preventing the activity. So drop, we can just discard the packet, throw it into a bit pocket, or we can dynamically create an ACL to prevent more data from coming from that source IP address. Resetting the TCP connection. Let's say, you know, you have a TCP connection, you all know about the handshake, and then you can reset it. Say, okay, doesn't look good. Let me reset it and start from scratch. Blocking future activities and allow the activity. You're saying, you know, it looks suspicious. I'm not really sure. I'm going to allow it and I'm going to monitor. So these are the actions that an IPS solution can take. And this is why people like IPS, because you're capable of taking an action. Okay. With IDS, okay, you can't really do real-time action because the action already took place. Okay, the data arrived at the target. With IPS, it hasn't arrived at the target and you can take action before. Okay. Deny attacker, reset TCP. All right. Monitor activities. So when you have an IDS IPS solution, you certainly want to monitor. You want to monitor and see if something is going on. And there's an awful lot of education that happens by monitoring, right? Everybody monitoring doesn't mean you're just looking for bad things. Monitoring also means you're learning. You're learning by monitoring. And if you don't believe me, just run Packet Tracer and go into simulation mode and click on next, everybody. And it's a great educational experience because you can see what is going on. And if you suspect something is suspicious, then this is good. Investigate it some more and see if it's truly suspicious or just some housekeeping protocol that is doing its thing. So we're talking about logging here, everybody. We have two ways to log. We can use syslog. We've covered syslog. We use it in our lab today. And then the other one is SDEE protocol, which is a communication. It's a Cisco communication protocol, so you can send the log events to a network management console. And Cisco doesn't only have a long list of hardware products, they have a long list of software products as well. And they have this thing called the network management console, and you can log to it. You can log to a system log server. We will do this today. You can log to an NMC, and then if that's what you want to do, you have to enable and use SDEE, which is a communication protocol. Okay. And we've covered this, everybody. You can have sensors wherever you want. Forgive me for asking, so where is the best place to have an IPS sensor? Anybody? Best place for an IPS sensor?
I'll admit I'm not sure.
Okay. Someone else? Where's the best place for an IPS sensor? The absolute best place. The one place you want to have an IPS sensor. Say it again, Cody.
It's right at the border.
Yeah, right at the border. There's that router that connects you to your IPS, and just behind it, immediately behind it on your enterprise side, that's where you want to put an IPS. Okay. And that's like the bare minimum, is because that one place is going to capture 100% of the traffic coming into your enterprise. And before it gets anywhere, I mean, you just went through the router and boom, you hit IPS. And if you're only going to put a sensor in one place, that will be the one place to put it, because it's going to capture 100% of the traffic. I'm not saying you can't put sensors in other places, but that would be the one place where you absolutely positively want to put one. Cisco is selling its services. So Cisco is the 800-pound gorilla. They have a large number of products and services. And let me show you. And this sensor base, everybody, in fact, let's try it. Cisco sensor base. Intrusion prevention, sensor base. Nope, don't want this. Yep. Sensor base is going to take you to Talos. Everybody, please make a note. Everyone, take your pen, your smartphone, however you capture your notes, and capture Talos here, right here. And all you have to do is just Google TALOS, and it will take you there. Okay. And this is Cisco Worldwide Security Management Map. And they're showing you what's happening worldwide, real time. Okay. And if we are to focus on the United States, I don't know if this is Vancouver, Canada, or Seattle, probably Seattle. Okay. And they're telling you, you know, this is what's going on in this geography as we speak. Okay. So they have, so it's a service they are selling, and they're telling, you know, we're monitoring data worldwide. We are learning from monitoring data worldwide. And anytime we learn about something in Japan, in South Africa, anywhere in planet Earth, we update our signature files, and then, you know, we make them available to you. So you don't have to wait very long before you have a remedy for that vulnerability. And they're probably right. I mean, they are the 800-pound gorilla. They do business worldwide, and they would know if a malicious activity has taken place in one part of the world. And they have, this is a team. So they have a Talos team, you know, hundreds of people, hundreds of specialized security people. They're monitoring the traffic worldwide, and they're learning from it, and they're updating their signature files to capture the latest and greatest in vulnerability attacks, just like anti-malware vendors do, Symantec, McAfee, Microsoft, etc. So everybody, if you can just write this down, TALOS, and you will see this again and again. Yes, Cisco is selling, and we can't blame them. They gave us this curriculum, and they didn't give it to us because you know, they have big hearts. They gave it to us because they're trying to convince you and me that they have the best of whatever you need. And when you are in a purchasing position, you know, hopefully you will remember Cisco. Not that I'm bad mouthing Cisco, I don't blame them. I do the same thing because they have a large team of people that is putting this curriculum together and keeping Packet Tracer up to date, and it's costing them many millions of dollars a year, and they want to get some value, financial value out of it. Okay, slides. Moving on. Yep, this is what we were looking at just a minute ago. And that's what I thought, you know, sender base is the same thing as Talos. They keep changing names. So I don't know what the most recent name is. I know it as Talos, and it still works. So they can all, over and above doing all the things we've talked about, they can classify IP addresses. So they give the different IP addresses a reputation or a blacklist. And a blacklist means this is a bad actor. Everybody, we're not going to allow any data from this bad actor. So maybe it's some office in North Korea or St. Petersburg, Russia, or whatever it is. And it's known that this is what those guys do, and it goes on the blacklist. And reputation is one step short of blacklist and saying, okay, on scale of 1 to, I don't know, 1 to 5, let me give that IP address a reputation of this is a kosher, you know, you can trust them. This is Microsoft, this is Google, this is, and I'm not saying we should trust everything that comes out of Microsoft and Google, just play along. Okay, so we don't have to worry about them. Someone else, okay, you know, we're going to give them a reputation of 3 because we've seen some malicious activities come out of there in the not too recent past. And whenever you see this image over here, everybody, this is an ASA. This is a Cisco Adaptive Security Appliance. And we will be covering ASA, I think, starting in Chapter 8, if not Chapter 8, Chapter 9 for sure. And Cody, I haven't forgotten. So hopefully, you know, before we get there, you and I can meet on campus and I can give you a physical ASA, a more recent one. You told me you have a very old one.
So I actually bought a RAM upgrade for this. The 5520, the reason I bought it because it has gigabit. So I found the new ASA software.
Okay.
So after I put the RAM in it, I should be good.
Okay, good, very good. We'll just remember that offer. So, and a security appliance is a security appliance, everybody. Security appliance does all these different things, you know, it's a firewall, it's an IPS, or at least, you know, you can buy one of those modules for your ASA and you plug that module in and now it gives you IPS capability. And you can even run anti-malware on it. I don't know if you guys know, you know, you can run anti-malware on your home wireless access point. Not all of them support that, but many of the higher end wireless access points, you know, it has a firewall built into it that is a must. And they will say, look, you know, if you want an anti-malware, you know, that is an additional service. You pay for it, we will download it. And then everything that gets inside your house, before it gets inside your house, we will make sure that it is not a known malware. And that is a great place to run an anti-malware. I hope you all agree. Before it gets to your PC, before it gets to your smartphone, before it gets to any device inside your house, it's being checked at the entry point, your wireless access point. So ASA is a security appliance, which covers several different security features. Think of like a security suite in hardware form. Implementation. So before we dive into the IPS implementation, and the first part for me is more important than the second part. I'm just being truthful with you because I want to make sure you understand what IDS, IPS is, what the pros, the cons are, you know, what the benefits are, what the disadvantages are. We talked about false positive, false negative. We talked about risk appetite. I want to make sure you understand this because the odds are these are the kind of questions you have to deal with when you go for an interview. Just like ZPF, no one expects you to have working IPS experience. They may teach you, but they expect you to know what it is. They expect you to be able to speak intelligently about it. Not so much that I have working experience. So they expect you to have firewall skills and ZPF. Okay, it's the next step. Let's call it next generation. But there's no escaping the ACLs. And if you understand the ACLs, then it's not that hard to go one level up to zones and then do the firewalls at the zone level. So knowing what ZPF is good. Having working experience, not necessary. Knowing what IDS, IPS is important. Having working experience, not necessarily. And if you end up working for an enterprise of larger than tiny, they probably have a security expert, because that's what I would do. If I have my own company and it's a small company, I'm not going to be expecting, you know, people that are doing everyday system administration to be security experts, because that is a niche skill. And I would feel much more confident if I have a security expert. Making sense, everybody? This is what the whole cybersecurity program is about. And you may get the training you need to get there, and those tend to be higher paying jobs. I don't know how well you'll sleep at night, but they're definitely higher paying jobs, because it becomes your responsibility to secure the enterprise. Questions on anything? I'm looking at my clock. We have 2 labs that will probably take us 20 minutes. So we're good time-wise. No? Are you telling me I've done such a fabulous job that you can answer any IDS, IPS question short of technical details?
No, absolutely not. I just don't have enough. I need to read more to be able to ask questions. As far as what you've explained, yes, I get the gist of it, but I need to read
good.
more so that I can
Good.
ask questions.
Good. And I'm really talking 1,000-foot level. So the first part.
Yeah, I'm right there with him as well. Like, I need to read more into it and do some
Okay.
stuff.
Good. Good. Thank you, Robert. Yep. But at 1,000-foot level, I am hoping, yep, I know what IDS is. I know what an IPS is. I know what the difference is. I know what the pros and the cons are. That's 1,000-foot level. And I would be surprised if at an interview they will dig any lower. So let's talk about implementation. Download the iOS IPS files. This is why you will need the public key for Cisco. This is a one-time event, everybody, a one-time event. You put it in the configuration file once and you're done. Okay, and then when you type show run, it will show you the public key. And remember, those files change, I'm not gonna say daily, but regularly, just like your anti-malware signature file changes daily. You know, they change regularly. And then you want to create a folder on your flash, and you want to configure the crypto key. The crypto key is that public key I was talking about that you do one time. So you download the files and then you have to configure the crypto key, which is the Cisco public key. And then you want to enable IPS, and then you have to decide which signatures you want to load into RAM. And a lot of that depends on how much RAM you have and how fast the CPU is. So the reason why you don't want to enable everything, because it's going to slow you quite a bit if you have a low-end hardware. And this is why Cisco said, do you want everything? You want advanced? You want basic? Based on your hardware, how much RAM and how fast is your CPU? It's inline. Just the one word you want to remember is inline. And there's going to be a tax. There's no escaping that. Anytime you go through a device, you have to pay a tax for going through that device. How big of a tax is the question. Okay, and the technical details. So let's just do the labs, because you will see these in the packet tracer file. So we only have two. The first one is about mirroring. I want to talk just one little bit about chapter 6, everybody. So I'm working on the labs for chapter 6. You can see I have a bunch, but I'm not done. So today is Thursday. This will change by Sunday night. But I'm working on it. I'm making progress. And then next week I'll work on chapter 7 and 8. I don't think there's much to chapter 7. Chapter 7 is all talk, everybody. And maybe we will combine that week with chapter 8. And this is why I'm becoming very confident about the timeline. We're doing good. Anyway, it's work in progress. 5. So let's do the port mirroring. And we need port mirroring for IDS, because IDS is offline and we want to send all the data to it, and switches don't do that by default. So we have to configure each switch to say, send a mirror of this traffic to this port. So we are in yellow, right? MLS1, yep, in yellow over here. And what you have to do is monitor session 1. So we have to create a session, because you may have more than one sessions. You may want to send half of the port's data to one port and then the other half to a different port. Making sense, everyone? So each of these become a session. And then interface FA010203 and send it to FA04. Straightforward. So anything that goes through port 1, 2, 3, send a copy to 4, because 4 we have a monitoring tool. We have an IDS running on 4. So let's copy and paste. And this is on the switch. So monitor session 1, we can have more than one. And if you were to look at it, source ports 1, 2, and 3, and destination port is 4. Straightforward, right, everybody? And if I had an IDS running on one of those ports, then I want to send the traffic from all the remaining ports. And I can do a range 01 through 24 and send it to this port. Okay. And let's watch it. Let's simulate. And we're going to do the ARP thing. You're all familiar with it. And what's the IP address for LT3? 101. Okay. 192.168.1101. And we're going to ARP to resolve the IP. And that is a broadcast. So that is legitimate, everybody. So ARP is broadcast. So we broadcast it. And 3 is going to reply. And this is where the NIC is acting at layer 2. Remember I said NIC, network interface card, is unique. It is at layer 1 and layer 2. Layer 1 because it's connecting the computer to the switch. That is a layer 1 activity down at the cables, sending zeros and ones. And layer 2 is where we're filtering. And the NIC for LT1 at layer 2 looked at the destination MAC address and said, this is not mine. I'm not going to let it in. And this is not mine, not mine. And if we wanted to, if this was a production environment, you can set the NIC in promiscuous mode, and it's going to say it's not mine, but I'm going to let it in, because my owner is either a hacker or we have some kind of a monitoring tool running here. So we're going to reply. Can you see, everybody? We're sending every time a frame is arriving at MLS1, it's sending a copy to server 1. Right now, server 1 is saying it's not mine because NIC is doing its job. But if we were running an IDS here, we would set the NIC into promiscuous mode. So we would allow the traffic in. So ignore the X for now. And I have no means of setting the NIC into promiscuous mode in Packet Tracer, but that's what we would do. So let's see the next one, everybody. Okay, so I can sit here and do this, and you can see every time this is a new frame, we sent a copy to server 1. Okay, we sent a copy to server 1. Are we good? Does spam make sense? Does everyone understand why we need spam?
Yes.
Okay. All right, any questions here? This is lab 1, believe it or not. All right, let's do our last lab for today. Is there anything else? No, that's it. Okay, I put this file together maybe for me, everybody. Okay, truthfully for me, not so much for you, but I'm gonna quickly review it with you because it says quick IDS IPS review. There are some useful links here. I would say click on it and spend a few minutes. And do you remember Talos, everybody? So this is the link for Talos down here. IDS, IPS. IDS is offline, passive. IPS inline, active. The Cisco iOS IPS acts as an inline, real-time intrusion prevention sensor. We're talking about logical sensors here. We're not talking physical sensors that scan packets and sessions as they flow through the router to match any Cisco iOS IPS 5X. This is their latest version, signature and/or pattern. The Cisco IPS has several detection methods for finding exploits, but signature-based. We're not talking about a malware signature, we're talking about an attack signature, so make the distinction here. And statistical anomaly-based detections are two dominant mechanisms. Signature-based, is based on a dictionary of uniquely identifiable patterns, okay, or signatures in the code of each exploit. As an exploit is discovered, its signature is recorded and stored, and this is Cisco selling its services. Statistical anomaly takes samples of network traffic at random and compares them to pre-calculated baseline performance level and say, this doesn't look right. This just looks weird. And then what do you want to do about it? Do you want to monitor it or do you want to take action? And that really depends on the enterprise appetite for risk. Categories, we have signature-based, we have policy-based, and remember, IPS is configurable, and you as a user can create policy-based, so you can create those, and they will probably generate false positives early on, but maybe you can tweak them and make them more reliable, anomaly-based, and a honeypot-based. We talked about all of that. Signature attributes, type, trigger, action. And action is what differentiates an IDS from IPS. So type and trigger is the same for both. Action is really what distinguishes IPS. You can take action before it arrives at its target. Signatures are categorized as atomic or composite, a single packet or a series, a sequence of operations. We talked about the two different types of IPSs, okay, host-based and network-based, and we talked about the pros and the cons. The biggest advantage for host-based is you can look at encrypted data because the host will decrypt it. The biggest disadvantage is it's a tiny scope, and we can flip that for a network. The biggest advantage is it's a large scope, every piece of data coming in from the outside. Disadvantage, we can't look at encrypted data. IPS can be configured to prevent the following attacks, blah, okay. The term false positive, we talked about it. It's a kosher activity that you took some action against. False negative is it was a malicious activity that you didn't take action against. And Cisco is saying the Cisco IPS is limited to signatures it's configured to look for. Okay, we're stating the obvious here, just like saying an anti-malware is only going to capture malicious files that are included in the signature file. Okay, and it changes. We talked about the SMEs, everybody, signature micro engines, okay, atomic, service, string, multi-string, but just to come down to the end. So these are different SMEs, okay. So we have a multi-string, a service HTTP, a service TCP, and where do we have a string ICMP, which is the example we're going to be doing today. So these are all different SMEs. Okay, where am I? Good. Okay. Each of these SMEs is used to process different categories of signatures based on the amount of available RAM, and I can say speed of CPU. And Cisco said, okay, you can do all of them, you can do basic, or you can do advanced. Okay, and maybe I should have put advanced before basic, like this. So this is all, this is more, this is less. Again, based on RAM and CPU speed. This is really important, everybody. The Cisco IPS can take one of the following actions: produce an alert, okay, good. Deny, okay. Drop, but don't reset the connection. We're just dropping that one atomic packet. Reset the TCP connection, you know, break the connection and force them to re-establish the connection. Deny the attacker inline, dynamically create an ACL that will prevent at that very first firewall, we're saying we're not going to allow traffic from that IP into our enterprise anymore. Even before it gets to the IPS, we're just going to prevent it. Okay. We talked about the two different ways we can log. syslog is what we will do because we have a syslog capability. SDEE is a communication protocol that uses some Cisco product, which we don't have. Okay. These are some signature files. And then we have risk rating, everybody. And Cisco is going to rate all of these risks. So when they capture a risk, they're going to say 25%, 50%, 75%, 100%. And 25 is information. 50 is low. I know 50 doesn't sound low, but according to Cisco, it is 75 and 100. And you will see this when we look at the log file. For ICMP, it's going to say, this is just informational. And then we have a bunch of terms here, retire and unretire. Retire means don't load into RAM. Unretire means load into RAM. Enable, disable. Enable means enable an action. Disable means, disable the action. Compiled versus loaded. Do you want to load it into RAM? Back to how much RAM do you have and how much do you want to load into that RAM? And it is a lot. So last time I looked, Cisco had several thousand attack signatures. Everybody, several thousand. And if you were to load all of that into your RAM, it's going to consume a lot of RAM. And the other consequence is it's going to take longer to go through it. So as IPS is doing its job and checking data against these known signatures, it's going to consume more time and more resources. And you don't want your IPS to be overwhelmed because it's an inline device and you're going to slow everything down. All right. Like I said, I think I did this mostly for me, but I made it available to you. So let's do the lab. So yes, we do need the security K9 module, and it's enabled on the router. Devices and routers are configured. Good. Security K9 module installed. Let me double check. Yep, it's installed, so it's there. Okay. Packet tracer has limited support. Yes, very true. In fact, it supports one signature. And I tried. I think I probably spent, several hours trying to find, what other signatures I can use. And it supports one. So we're covering it today, and that's your assignment for this week. And yep, very good. In fact, let me check something really quick. $285 packet tracer, week 5. Yep, and that's why I didn't give you the details. Okay, and then for 6, this is what I have, and it will change before we cover 6. Okay, so let me go back to that one slide. Let me kill this. And here you go. Okay, no, not this. Enable load. Maybe it is this. And this is the public key, everybody. And that's what you load into your configuration file. Maybe it is this. Okay, these are the steps. So I tried to mirror these steps just so I can map it to what Cisco said in the slides. Okay. So we create the directory. Do I have steps? I don't have steps, but I do have description in blue. So we create the directory. Okay. and then we enable IPS in this flash directory. Create IPS rule. Okay, so we created it and we named it. For logging purposes, server 1, and I will show you services syslog is enabled, so we're going to capture the log information here. Okay, very good. I enabled timestamp, so I can capture date, time down to the millisecond. And of course, this is a must in a log file. Not only do you want to know something happened, you want to know exactly when it did happen. Okay. Configure signature categories. Remember, the 3 categories are all advanced and basic, and Packet Tracer only supports basic. So I'm saying signature category, category all, retire true, meaning retire it. I don't think it does any good because it's not fully functional on Packet Tracer. And then category basic, everybody, and retire false, which means enable it, which means load it into RAM, and then apply it to gig 00, and gig 00 is this interface here on R1. And then what signatures do I want to unretire? Because you don't want to unretire all of them. You want to retire the ones you want, and we're limited to 1 on Packet Tracer. So unretire echo request signature, signature ID 2004, sub ID is 0, which is the ICMP. Okay. So IPS signature definition. This is the signature ID, sub ID status, retired false, enable true. Okay. And then what alert and action do I want to take? So this is the type. Everybody remember type, alert, action. And then what do I want to do? I want to produce an alert. Okay. And I want to deny the packet from continuing on. So this is what this does. So I'm going to copy and paste. And I'm going to come here and paste it. And you can see we loaded a bunch of stuff into RAM, not a whole lot because we don't have a whole lot to load. And we enabled the logging, which means we probably already have something logged. So some syslog, here we go. So we already captured some activities in the syslog, and we'll be capturing more. Okay. So show flash, and you can see the directory we created, and then we copied those files into it. Those are the signature files that are provided inside Packet Tracer. Show IPS question mark. Okay, and we can do config, and we can do signature, and we can do all. So I'm going to do signature count. Okay, and we have a total of 1 signature, and it's unretired and it's enabled because that's what we did. And then if you want to look at that 1 signature, sig ID 2004, sub ID 0, and this is the signature. This is what we loaded into RAM. It's an ICMP signature. Okay, so let's see what we did. You're not going to be terribly impressed, but that's pretty much all we can do inside Packet Tracer. So ping from the inside, success, ping from the outside, failure. So this is the outside, yellow is outside, blue is inside, so I should be able to ping to the outside. Ping. What's this? This is 2. 192.168.22. Success, okay, there's no alert, no action, and then the opposite, and this is 1, 2. So let me ping from the outside 192 dot, and it's going to fail, and it's going to generate an alert and an action, and the action is it's not allowing it in. Okay, the IPS is dropping those packets. And now if we are to look at the log file, you can see it's growing as we look at it. And we're going to expand it so we can see everything. And it's saying IPS 4 signature, signature 2004, subsignature 0, severity 25, which is informational. Do you guys remember the rating? 25, 50, 75, 100. And the source is this IP, the destination is IP, and the risk rating is 25, which is also informational. But we did take action. This is as far as we can go with Packet Tracer, and your assignment is similar, a different topology. Any questions on IPS, IDS? I am most interested, yes, I want you to do the lab, and you're going to have to get into some details, and I believe they give you the details. But I'm most interested in making sure you understand IPS at 1,000-foot level. And if you end up managing IPS, you're going to require additional training. And everything we do in our network and system administration, it's basic. It gives you the basic tool set, and IPS, ZPF are not basic tool set. Those are intermediate to advanced, especially IPS, because you're going to have to create those policies and you're going to have to constantly tweak them, and you want to be secure, but you don't want to produce too many false positives, and you definitely don't want any false negatives. So it's a niche job that requires a good deal of technical training, which you're not getting from me. But you can talk intelligently about it. Questions?
I don't have any right now. I probably will next week after I've done the assignment.
Okay, good. Then, send me an email, make a note. Next week, we're covering chapter 6, which is good chapter. And we have a whole week for chapter 6. So we're in a good shape, everybody. So we will do maybe 60% of chapter 2, 70% of chapter 2 on Tuesday, and then we'll finish it on Thursday. And it will be good. Chapter 6, did I say chapter 2? Chapter 6 is good. So you will learn some useful stuff that you can put to use right away. And then chapter 7, we change directions. We start going in a different direction, starting with chapter 7. So if I was to put a middle point, I would say chapter 6 is part 1 and chapter 7 on is part 2 of this course. Are you comfortable with what we've covered today? Not, the instructions that we did inside Packet Tracer. I don't expect you to be comfortable with that yet, but up to the slides.
Yeah, while you were going over the slides, I was also trying to read through the security portal command guide and just kind of like reference what you were covering the slides with what the book was talking about, and a lot of it did start to make sense, but it goes back to I just need to do the practical application, and then I think it'll all mesh together. Good.
And one thing I would love you to do, and I hope you're already doing this, is there's a ton of material out on the market. And yes, Cisco is the 800-pound gorilla in the networking field, but there are lots of companies out there, Palo Alto Networks, FireEye, et cetera, and they all have IPS solutions. And one thing I strongly encourage you to do, everybody, just let me show you, is to Google. We're done here. The very last 2 files in my folder were the assignments you're doing, because I did your assignment, but I'm not sharing that with you yet. So here, everybody. So go to Google. Okay. IPS Solutions, or you can just do IPS. I bet you know it's big enough. It's not Indianapolis Public School. Okay. How about if we do Cisco? No, I don't want to do Cisco IPS Solutions, because then it's gonna zoom in Cisco. Here we go. Okay. Barracuda, Altas, I don't know, this company. Okay. Intrusion prevention system examples, Trend Micro, Hillstone. Okay. What is an intrusion prevention system? Who is this from? FacePoint. Okay. NDM. Here we go. Okay, Palo Alto Networks. I hope all of you know about Palo Alto Networks. They are a massive cybersecurity player, and they're really, really good. They have top-notch products and services. I will be surprised if you don't come across some of the Palo Alto solutions down the road, and then you can click on it and get educated. And of course, eventually they're gonna get you to their products and services. But before they get to products and services, they wanna explain what it is. And this would be something good to do after you've looked at the slides, or after you've got, please don't look at the slides. Go straight to the Net Academy material. It's much richer than the slides. The slides are a subset of that. And then, you can spend some time just to see what is happening out in the industry for IPS. And I will repeat myself, this is where a lot of innovation is happening. Firewalls are legacy, stable, wonderful, we love them. Anti-malware, legacy, stable, do a fabulous job, we love them. IPS, a lot of innovation is happening there. So it's a maturing, it's not legacy. I wouldn't call it that yet. I would say it is a maturing technology, and a lot of innovation is happening there. And Palo Alto Networks, very good. Cisco, very good. So there's a bunch of top-notch players there, and they focus mostly on the network IPS, not the host IPS. That's the McAfee's of the world, the semantics of the world, etc. That's all I have for today. Unless you have questions, we can call it a day. We can call it a week. This is week 4.
One thing I was just thinking about, and I probably should look at the lab first, does the lab show us any logs or have us go through any events of intrusion detection? Like it detected a intrusion, not just the normal, somebody tried to enter the wrong password, but like an actual event?
Are you talking about the lab for chapter 5, which is IPS IDS?
Correct.
Okay. Do you see the lab we did together?
Yes.
That's your lab, except it's a different topology.
Okay.
So remember, packet tracer supports a single signature. So that's all we can do.
Okay.
Use that single signature. And I desperately wanted to do something different from what you guys are going to be doing. And there's just this one signature.
So then
it's
this
not going to
brings
be
up
much different from what I did.
So something I was wondering, and we did it 2 terms ago. The NetLab, would we be having a lot of these same limitations with the NetLab stuff as we are with Packet Tracer, or no, since that was technically real equipment?
Yeah, it's no. I mean, if you were to IPS on a Cisco router is much richer than what we're doing with Packet Tracer. You can actually see all these different SMEs. You can actually download signature files. We wouldn't download very many signature files, but we can download one signature file with a bunch of different signatures, and then we have a lot more flexibility. And if you want to see what you can do with the classroom computer, look at the other lab in chapter 5 that you're not doing. So, you're going through the Net Academy material, and then it says lab, and there's one lab that will ask you to download the signature file, configure the Cisco public key, unpack all these different signatures, do a bunch of things with a bunch of different signatures. You can do that on a real device like Cody can, but the rest of us that are limited to packet tracer are limited to this one signature. Did I answer your question, Frank?
You did. Thank you.
Okay. So next time we go back to campus, and this morning I was watching the news, and a bunch of universities are already announcing they're going back in the fall. None in Oregon yet, but in other states in the United States, they've already made the decision, we're going back to campus in the fall. So we have to wait for Oregon to decide. But the probabilities are going up that we're going back to campus in the fall. Summer will be online. We don't really do much in the summer at LBCC, but it's going to be online, and then we're waiting to see what the decision is going to be regarding fall, and maybe it's a bit early to make that decision. Did I interrupt somebody?
No, I was just going to say the school sent out a message. I think it was yesterday. The summer term's going to be online.
Yes.
But I think for most of us, that shouldn't really matter.
No.
We should be finishing
Network and
this.
system administration, there is absolutely nothing you can do online.
Well, I mean, I think
For the
for
summer.
most of us, we're graduating this term, hopefully, fingers
Good,
crossed.
good. Yeah, that's wonderful. That's wonderful. And that's why I keep talking about job interviews, because I know a bunch of you are graduating this June. And hopefully you already have a resume and a cover letter and started the process of looking. No questions?
Zico, I actually wanted to talk to you a little bit, not necessarily subject matter about this class, but just a few things after everyone else who has questions about this class has asked them.
Okay. Any other questions? Then if you want to stay and listen to the rest of us talk, you're welcome. If you want to leave, have a great week, and I will see you next Tuesday. Go ahead, Zach.
So for the past week, I've been having a lot of issues with my computer. I guess my computer about for running simple tasks. My PC is always using at least half of its CPU, and it makes it really hard to do anything in Packet Tracer. I had a lot of issues this week with the 3.1.1.5 Packet Tracer.
Yes.
Running the simulation modes and stuff. It just kept filling up the buffer on my computer and just couldn't run. It made it really hard to get stuff done, especially this past week. I know you've talked about before flashing your PC and reloading the operating system. I go into Task Manager a lot, and Task Manager does use a lot of CPU to start up. But right now, I'm running at 60% CPU just to be on Zoom.
Yes.
I feel like I have a decent amount of malware or something, probably just stuff that.
So may I show you a couple of things, Zach?
I'm sorry?
May I show you a couple of things?
Sure.
So I'm in Task Manager, and if you click on CPU once, it's gonna sort everything, all the processes running in one order, and if you click on it again, it's gonna sort them in a different order. So I want the processes that are consuming the most resources at the top, and then you can do the same thing with memory, you can do the same thing with disk, and you can do the same thing with network. So in my case, disk and network are not using any, so I'm not concerned about it. But let's say I'm concerned about memory at 59%, and it's showing me Google Chrome, is your number one and it's showing me Microsoft Edge is number 2. So this would be a good way of capturing, which process is eating up your resources.
Mm-hmm.
And if it's a legitimate process, and then you can right click on it, and then you can search online. Let's say, you see a name you're not familiar with, you're saying, I don't know what this thing is, then just search online and see what you can find about that process. And it will tell you if it's legitimate or illegitimate. So I don't know what's happening in your PC, but you may have something running that is consuming all these resources. And if it's something that is running and you don't need, kill it. Maybe it's some process that you don't really need. And
maybe you have a bunch of processes that start when your computer starts up.
I went through those and I deleted them.
Okay.
I find that there's a lot of like system services and like the services controller app and stuff like that. Things that all like, the reason why they consume so much CPU is because something else is acting incorrectly,
Yeah.
And I keep getting like these weird antiviruses show up on my computer that I never downloaded.
And I did talk about, every now and then, Zach, I did talk about every now and then I do install a brand new, fresh copy of Windows 10. And that's not a bad thing to do. And you can go to Azure and you can download a free copy of Windows 10. And you can put it in a USB and make sure you back up your files. That's the most important thing that you want to back up. And then this is worst case scenario. I'm not saying do this, but if you can, to resolve this issue, maybe reinstalling Windows 10 and reinstalling the applications and restoring your files is not a bad way to go.
Yeah.
What kind of PC? What kind of hardware is it, Zach?
It's an HP. It's
well, that's your problem right there.
Yeah, right.
Hey, wait.
Yeah.
It's like it's like a really low end gaming PC. I mean, it's got like AMD Ryzen Radeon graphic type stuff, and it has decent components really, but it just runs like crap all the time.
So I'll say this: if you want to put TeamViewer on your computer and then let me log into it, I can look through and try to figure out what's eating up a lot of it. Some of it, I have an HP laptop, and there is some bloatware that gets put on it. Some of it's like
is it a laptop
cooling
Zach?
for services.
Yeah, it's a laptop.
Yeah.
Oh, I bet you have so much bloatware on that thing.
Yeah.
Yeah, I don't know how to get rid of all this stuff.
Well,
like these weird services.
Frank just made you a wonderful offer, and I really appreciate you doing that, Frank. So maybe the two of you exchange phone number, email addresses, etc., and can take a look. Worst case scenario, just worst case, reinstall Windows 10 and reinstall your applications. But
he's got to be careful about reinstalling the Windows 10 on a laptop, because there's a lot of internal components that if he gets rid of those
proprietary drivers they have,
then his laptop will just shut down and not work.
Well, it's a possibility, but you know it's pretty good. Windows 10 is pretty good, especially if it's Hewlett Packard. It's a large vendor. This is not some side vendor. They're not going to use some weird components. So I would say the odds are pretty high that the computer will function just well afterward. And if there's a particular component that isn't working, then you can download the driver for that one component that isn't working. Let's say your Wi-Fi NIC isn't working, then you can download the driver for that. But I've had good experiences. I'm mostly a Hewlett Packard Dell guy, and I've installed Windows a gazillion times, and it almost always works.
On the laptops?
On laptops, yeah.
Okay, gotcha.
And I'm not trying to badmouth HP. I'm just saying that's most laptop manufacturers, that there's some sort of, like for mine is an HP, and I went from Windows 7 to 10, and I just completely wiped it and put 10 on there, and my touchpad stopped working. It took me forever to find the correct driver install to get it to work.
And remember, if you install Windows 10 from Microsoft, it's not going to have all the crap Hewlett Packard Dell put on their laptops. So there, you know.
It seems like my problem is I found that these random executable files that run in the background just like show up out of nowhere and start running.
Yeah.
And I don't know where they come from. Like this antivirus software, anti